Hello guys and welcome back to another quick maths tutorial. So today we're going to be looking at integration again, but we're going to be solving more types of functions inside of an integral, because before we were just looking at when the integrand, the thing inside the integral, is a polynomial, which are quite easy to solve. And today we're going to be looking at something called u-substitution, right? I'll explain more about this. But first, exclamation mark, very important. We're going to be looking at basically some rules of integration I didn't go over in the start. So these are quite small, so not enough for their own video, but also really important. So I'm just going to list them. Okay, so rule number one, the integral of f of x plus g of x dx is basically the same thing as the integral of f of x dx, so I'll move my hand a bit, plus the integral of g of x dx. So these, you can split, you do each term separately, which is what I sort of assumed you'd get along with fine, but maybe if that was seeming like a step I missed telling you about, you can do this, and it's you can also do difference as well. So imagine g of x was you're taking it away, you could also do that. Another one which is quite important is this one. So c represents some constant and we're timesing by it. So we've got, if it's inside the integral, we can take it out, right? We can just move it outside. So that's a quite important one. And you can just assume you can, as long as it's a constant number, it's got no variable like u, x, y, anything anything that's basically can have multiple values. Where something that's got a set value, like c, is a constant, and you can take it out. So they're the rules. And let's move on to u-substitution. Okay, so basically, if we have an integral in the form f of g of x multiplied by g dash of x dx, we can use u-substitution, right? So it should look like this form. Now, it's not always going to look exactly like a composite function. It just needs to have some sort of complicated, so more than just one term, so a term raised to a power, adding another term to a different power, taking away some constant or whatnot, something that's not just a monomial, like a binomial, something like that. In terms of x, powers going on helps, natural logs, trigonometric functions, and then something else has been applied to the output of that, so of course using your PEMDAS, and we're multiplying by what is the same as the derivative of our original function. We can just say let g of x equal u. Okay, so we just say it's the variable u. Therefore, du dx, so the derivative of u, well, that's going to be g dash of x, the derivative of g of x. We can multiply both sides by d of x. I know they tell you not to treat it like a fraction, but you can do that. And therefore we have the value of du is equal to g dash of x dx, which we do have here. So that's just du. And g of x is just u. So this whole thing becomes the integral of f of u, so the outside function of u. We can keep these in terms of u, so all the x's are gone, we just have u's now, du. And the du is called the differential, and this means what variable are we integrating with respect to, like differentiation on the bottom. So obviously if we still had x's we couldn't do it, but we've got rid of all the x's now, and this should be a simpler function as the one before. Okay, so a good example would be, I'll just do the one short video example. The integral of, let's say, x plus 1 cubed. You could expand this, but let's say you didn't want to, or something on a more complicated line, dx. Yeah, that's fine, we can do that. and I'll explain why. So first off, the inward function is x plus 1. I know that doesn't look like a function, but I said it's not as simple as one variable. It's x plus 1. So we can say, let that x plus 1 equal u. Therefore, du, I'm going to multiply both sides by dx. Well, the derivative of x plus 1 is 1. And multiply by dx, we get du is equal to dx. That's a nice swap. And so this becomes the integral of u cubed du. So just, if you don't like u's, treat it as x's again. X cubed dx, you can do that. You know, it's a polynomial. And we get, using the power rule, is equal to u to the 4 over 4 plus c, which we have to substitute back. That's the important thing. U is x plus 1, so we have x plus 1 to the 4 over 4 plus c. Right, so that's how you use it essentially. So basically just check it's in this form. If it's not, try and get it to be using some of these rules here. So split into individual integrals, or move constants out or move them in. So we could times this. If we have an integral of f of x, this is like another rule, dx, we could say that's equal to 1 over c times the integral of c f of x dx. We can multiply by a constant, then divide by it. And usually that's helpful for getting the derivative of g of x inside our integral, because it might be off by a certain constant, and we can change that and get it in the right form, this form here. And yeah, then we can apply u-substitution. So I hope this video is helpful. Look out for more integral videos. If you have any topics you'd like me to go, just please shout in the comments. Thanks for watching.